हेलो। 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 सर, एम आई ऑडिबल?
Hello, KK Singh sir. Hello, Shivam sir.
Yeah, hi.
So, do I start my presentation?
Yes, let's wait for Shivam sir. He will instruct how to go ahead. Shivam sir?
Yes, sir.
Okay, so should I share my slides? Yeah, it will be shared from the host.
Yeah, please, please turn on
Okay,
your camera.
I am sharing my slides and let's start it, the presentation.
Please wait for a minute.
Okay, okay.
I'm going to opening this session. So please.
Okay.
So good afternoon, everyone. A warm welcome to all the respected guests, speakers, organizers, and participants joining us from different parts of the world. I am Prata Gupta, and it is my great honor to serve as your anchor for today's international conference on women development in science and technology for achieving sustainable goals using statistical techniques 2025. This conference is organized by the MIT School of Applied Sciences, ASAS, MIT University Uttar Pradesh, Lucknow campus, in collaboration with Science State Institute, Lucknow. Today's conference covers as a wide range of topics, including mathematical modeling, environmental science, biostatistics, computational science, and much more. Before we begin, a gentle reminder to all the participants, please keep your microphones muted unless invited to speak. Kindly post your queries in the chat box. Selected question will be taken by during the question and answer session. So it is an honor to
Hello, Sweta. Should I start presentation?
Shivam sir, should we start this presentation?
Okay, okay,
Yeah,
sir.
Sure, Ankita ma'am. Start.
Okay, thank you, sir. So the slide is visible to all.
yes, yes.
Yes, ma'am. Yes, ma'am. Please go ahead.
Okay, okay. So I am Dr. Ankita Gupta. I'm an assistant professor in statistics section Mahila Mahavidyalaya in Banaras Hindu University. And the title of my work is Cure Rate Modeling with Random Competing Risk, a Bayesian approach under right censoring. So in this work, let me first explain what is cure rate. Okay, so in lifetime data analysis, we generally assume that each and every unit uh, will experience the interest of event of interest if we follow all the units for a long period of time. However, in certain recent advancement, like in screening, diagnosis, and treatment of disease, they have increased the longevity of certain proportion of subject, and this assumptions that we generally assume in lifetime data analysis that each unit will experience the event of interest may be violated. Let me explain this by an example. So let us consider a group of patients with a specific disease is being treated under a special treatment. So in the due course of time, some patients may be cured and some may remain susceptible. Cured patients are who are cured and they will not ever experience the same disease again in their life. And susceptible are the ones who are not showing symptoms at this time but may experience that disease but may have that disease again. So these kind of individuals are called susceptible. So here our population is consisting two types of individuals. One are cured, they will not feel experience the event of interest where even if we follow them for a infinite time, and another group will experience the event of interest if we following them for a long period of time. So in this scenario, precise estimation of proportion of subject who are cured or the cure rate, just we call the proportion of subject who are cured as cure rate. The estimation of cure rate becomes an important area because the patient who are having high cure rate can be protected from the additional risk of high intensity treatments. So, considering this fact, estimation of cure rates has gained significant attention in statistical practitioners, and cure rate models are being extensively, studied. Now, what is cure rate models? So, these are nothing but the extension of traditional lifetime models that allow for the presence of cured and immune fraction in the study population. That means cured fraction, the individuals who will never experience the event of interest. These models were originally developed in biomedical contexts, but since then they have been refined and extended to address heterogeneity, latent risk, and competing risk, making them a central tool in modern survival analysis and reliability studies. These are certain important reference that can be considered as milestones in the development of cure rate models. But a thorough literature review suggests that, however, there has been found a lots of works and development on cure rate models, but Bayesian development of these models remains relatively scarce. So, in this considering these facts, in this work we have focused a particular type of cure rate model, that is component mixture cure rate model, which was introduced by Bogue, and we extend this model to incorporate the possibility of experiencing the event of interest through a random number of competing risks. And we carry out a comprehensive Bayesian analysis of this generalized model. So, uh, this is the formulation of model. So, for formulating our model, let us consider a random variable, which is the failure time of the subject. And this random variable can be defined as the minimum of random number of latent lifetime, WIs. And we consider these WJs are identically and independently governed by Weibull distribution, having the PDF survival function and CDF as the with the form in equation 2.1, 2.2, and 2.3. Here in this model, we have considered the number of competing risks is again a random variable. So let M is denoting the number of competing risks, and it is governed by negative binomial distribution. And the PMF of this distribution is given in equation 2.4. So obviously, M following negative binomial distribution can assume value 0. And whenever M is assuming value 0, that means the corresponding individual or corresponding Y is going to be infinitely large. And that individual will be called as cured. So obviously probability M is equal to 0 will be the cure rate in our models. And when we combine the models of WJs and model of M, then the resulting model of Y will be called a cure rate model. Let us solve this model as Weibull mixture negative binomial cure rate model. And the survival function of our proposed model can be obtained as the following expression. it can be seen that the survival function of our model is nothing but the probability generating function of M evaluated at survival function of viable distribution at point Y. So the resulting survival function of our model can be found in closed form expression as in equation 2.6. And after obtaining this survival function, we can predict the long-term PDF of Y, our proposed model. And this is given in equation 2.7. Similarly, the cure rate or proportion of cured persons for individuals can be obtained as in equation 2.8. So in general experiment, we can observe that the cure rate is affected by a set of covariates. So to study the effect of such covariates in our cure rate, we have regressed the parameters gamma 2 and eta on the set of covariates using the following link functions. And the resulting expressions for survival function, PDF, and cure rate of our resulting model can be expressed in terms of regressor parameters as in equation 2.11, 12, and 13. And let us now denote the final vector of model parameters of our model by theta, and where phi is the parameter of negative binomial distribution, gamma 1 is the parameter of bival distribution, and alpha beta are regressor parameters. For formulating likelihood function, let us consider an experiment with n patients who are exposed to experience a random number of competing risks to experience the event of interest. And let us assume the failure time of that individual is governed by our proposed model. And let us assume that we observe for each individual the observations Ti, delta I, and xi. Ti is the observation on lifetime, and delta I is the right censoring indicator, where delta I is equal to 1 will indicate that the Ti is completely observed, and delta I is equal to 0 will indicate Ti is right censored. And xi is denoting the observed covariates for ith patient. So for this form of data structure, the likelihood function under the proposed model can be expressed as in the following equations. Next, to analyze this model in the Bayesian setup, we have considered independent and proper priors for the parameters. Particularly, we have specified normal priors for the regression parameters, and for the parameters gamma 1 and phi, we have chosen gamma priors, and we have chosen the hyperparameters in such a way that our priors becomes vague. And under these priors, we have obtained the corresponding posteriors, and which has been found to be in the following expression. And we have obtained these posteriors only up to proportionality. And it can be seen that this posterior is quite difficult to solve analytically. So we have proposed using sample-based approach in order to get the posterior summary. In particular, we simulated this posterior using a sample-based approach called Metropolis algorithm with multivariate normal distribution as candidate generating density. To briefly explain what is Metropolis algorithm, it is nothing but a Markov chain based tool to simulate a multidimensional distribution which requires only the specification of arbitrary symmetric candidate generating density. So let us assume that Q theta given theta dash is the candidate generating density. So at a certain step, say ith generation step, we will generate a candidate theta, candidate for parameters, posterior parameters, theta star for given theta I by using this candidate generating density. And this theta star will be accepted to be next iterated value theta I with the given probability. And if so, we accept this theta star as to be theta I with the probability rho. Otherwise, if the value is rejected, the chain will store theta I to be theta I minus 1. So in this way, we will simulate as
Ma'am,
many generation. Yes.
ma'am, ma'am, I humbly request to kindly wrap up your presentation within 2 minutes because
Okay, okay, okay. Okay, so in this way, we
participants
can
have only
simulate
8 minutes.
high-dimensional posterior density from this metropolis algorithm. Again, after we have also studied the compatibility of model for the chosen data, and for that we have chosen the tool posterior predictive p-value, and which can be evaluated using the formula 4.1, where and this p-value is defined is based on chi-square statistics. And for numerically illustrating our proposed model, we have used a data set by German breast cancer study, and this data set is available in our package under FlexServe, and the data set name is BC. So this is the data structure which contains the failure time, censoring indicator, and covariates. So before carrying Bayesian analysis, we have also obtained the ML estimates, and the ML estimates are shown in these tables. And we use these ML estimates and Hessian based metrics evaluated that at these ML estimate as the uh, initial values of posterior parameters and variance covariance matrix for our multivariate normal candidate generating density. And after simulating the posterior, we obtain posterior sample based inference for our model, and these are the posterior estimates for the parameters. And we can see from the table that if we compare the estimates, posterior estimates with the classical estimates, we can see the posterior estimates are found to be more consistent. And after obtaining the posterior estimates, we also estimated the cure rates of patient, and these were found to be 0.755 for good prognostic group, and 0.0991 for medium group, and 0.0115 for poor group. And partial posterior predictive p-value is also found to be 0.3907. That is quite ensuring the compatibility of model for the data set with hand. Now concluding our work. So we have considered a generalized cure rate model that can simultaneously accommodate the presence of competing risks, and we have developed a complete Bayesian framework, as the classical methods often becomes cumbersome when we dealing with such complex method. And we have demonstrated through numerical illustration that our Bayesian methodology is found to be quite straightforward and computationally feasible. And okay, so this was the objective of our work, to propose a Bayesian methodology, and our methodology is found to be more consistent in comparison to existing classical methodology. And these are the references we have referred throughout the paper. And thank you.
Thank you very much, Ankita ma'am, for this wonderful talk.
Ankita ma'am, can I ask one question?
Yes, sure.
The session is
In
open for question. Please.
in the cure function, you have used the breast cancer data. So how
Yes.
you have decided that the this patient is using for cure function, or who survived of you have categorized in three groups: medium
Yes.
breast cancer
High
patient.
prognostic group or medium
Huh.
group and
Yes.
poor
So
prognostic group.
how you have decided this?
That is given in the data set. जो
No,
मैंने
these are
regression
the category,
covariates
but how
ऑब्जर्व
you
किए
have
हैं,
decided that this category will be cure function or median? because in the function definition, we
Mhm.
use that the patient is haven't any chance to recur the disease or mortality or something time related.
Hmm.
But in this breast cancer scenario, this is not possible that the patient is purely cured. So how you have
Yeah,
decided?
I have mentioned, I have estimated the cure rate. So the cure rate for high prognostic group was 0.7 K, something around that is very good. And cure rate estimation tells ki which kind of treatment that group should be given. So that जो high prognostic group है, good prognostic group है, we should give that low intensity treatment, right?
Okay.
For the treatment of breast cancer, like there is I am not getting the medical term, कुछ certain rays pass करनी होती chemotherapy, right?
Yes.
So high
Yes.
prognostic group वालों के लिए वो जो chemotherapy की sessions होंगे वो comparatively बहुत lesser होंगे in comparison to low prognostic group that we have estimated through our model.
Ma'am, one query from me.
Yes, sir.
Can you suggest a few platforms where we can get the popular data sets for our research?
Few platform for survival data, there are very lesser. They are most of the data sets are not accessible, sir. We have to take certain kind of permissions from the authorities. But sir, for reliability data, there are lots of data set available in R. Flex में भी बहुत सारे data sets available हैं और भी packages available है
Thank you. Yeah.
data analysis से related. So we can get this kind of data set from there.
Thank you, ma'am.
Any other query? Anyone else?
Thank you, ma'am. Now I request number 39.
Okay, so
Miss
thank you all.
Nimita. Miss Nimita,
Yeah, I am available, ma'am. Wait, one.
please share your screen.
Is my screen visible to everyone?
Yeah, your screen is
Yes,
visible.
Nivita.
Good afternoon, everyone. My name is Nivetna, and I am doing PhD under the guidance of Dr. Mini Ghosh from VIT Chennai. Today, I will be presented my paper on the topic optimal control and cost-effective analysis for COVID-19 and tuberculosis co-infection. First, my presentation will cover an introduction and motivation, and then move on to model formulation and more mathematical analysis and cost-effective analysis and optimal control, and followed by results and conclusion. As we all know, TB remains a deadly infectious disease and it is a pandemic. Even though we have a proper treatment and recovery is possible in TB, still now TB is a pandemic disease. And now COVID-19 has recently added to the global health burden. Since both the diseases mainly affect the respiratory system, patients who are already infected with TB become more vulnerable when exposed to COVID-19 and vice versa. When exposed to this co-infection, not only worsen the health outcome for patient, but also makes control strategy more complex for public health system. To understand and address this problem, we construct a mathematical model. The idea is to take a real life health issue, translate it into mathematical equation, and use mathematical analysis to gain insights. With this model, we can study how disease spread together, how control strategies like treatment or prevention work, and which strategies are most cost effective. Considering this co-infection strategy, we have formulated a co-infection model with 12 different compartments. like susceptible, exposed, infected, treatment, and recovered. From susceptible, the people are divided into two groups and they are moving to exposed COVID and exposed TB at the rate of beta in contact with infected peoples. And people who are from exposed COVID, they are moving to infected and as well as infected to co-infected peoples. And here we have considered treatment compartment. For COVID, there is a natural recovery is possible. So we have considered two pathway for COVID, like direct recovery and through treatment. But for TB, and treatment is required for recovery. So we have considered only one pathway. And these are the corresponding differential equation where our total population is denoted as sum of all different compartments. And here, to analyze the co-infection model, we have divided the co-infection model into two submodels, like COVID only submodel and TB only submodel. First, I start with COVID-19 only submodel, which have only 5 compartments. And here lambda is the natural recruitment rate and beta is the transmission rate, and mu denotes the natural death rate. And here we have considered additional death rate in treatment as well as infected compartment. And psi 1 denotes the treatment rate and gamma 3 denotes the recovery rate. And then I just we have done positivity and boundedness and shown that all the system is positive. And then we move to basic reproduction number. Actually, the basic reproduction number plays a major role in infectious disease modeling, which gives an average number of secondary infections produced by a single infected individual in a fully susceptible population. In our model, we have considered exposed compartment, infected compartment, and treatment compartment as an infectious term. And using next generation matrix, we just calculated the basic reproduction number for COVID-19 only model. And these are the parameter values which we are used for our model. And here few parameters are taken from literature review and few parameters are assumed. And beta transmission rate is calculated for Indian in the infectious value in India. And for this model and for this set of parameter, we are as getting or not equal to 3.1514, which shows that in one infected person is possible to transmit a disease to at least 3 people. And here we have an endemic simulation of those set of parameters. After few days, it persists. And here I'm having a sensitivity analysis plot which shows I have used normalized forward sensitive index. Here, if the parameter has positive indices, which shows that the parameter can increase the basic reproduction number value, and if the parameter have negative indices, it can decrease the basic reproduction number value. From this plot we can find that lambda recombinant rate beta plays a major role, a transmission rate beta plays a major role in increasing the basic reproduction number, and psi 1 and psi 1 treatment rate and gamma plays a major role in decreasing the basic reproduction number. And then we just move on to TB only model. And here also we have considered 5 different compartments, and all the parameters are the same as explained in COVID-19 only model. And say using the next generation only matrix, we have constructed basic reproduction number for TB only model. And these are the parameters used for TB only model. And here also the transmission term beta 2 is calculated for Indian values. And here the basic production number is 3.7458 for this set of parameters, which shows that TB can transmit more than 3 people. And here I have a simulation of endemic equilibrium for those set of parameters. And sensitive analysis, here beta 2 transmission rate and treatment rate transmission rate plays a major role in increasing the reproduction number, and treatment helps to decrease the basic reproduction number. And now we just move on to co-infection model. For co-infection model, There's no any specific things to calculate basic reduction number. We calculate basic reduction number for co-infection model, which is like maximum of 2 submodels. So from our two submodel, we have found that for or not COVID it is 3.15 and for TB it's 3.74. So the co-infection, the basic reduction co-infection model is 3.74. That is TB value will accurate. And here I have equilibrium points of co-infection model. This is free equilibrium where the disease haven't started. It is at the initial stage and it haven't persisted. It maybe dies out also. But in endemic stage, the disease may persist. And here the stability results of basic production number. For disease-free equilibrium, the local asymptote is asymptotically stable when R naught is less than 1. It is proved using the linearization method of the Jacobian matrix. And endemic equilibrium, we have used bifurcation analysis like Castor-Sung and Sung theorem, and we have computed the constant satisfying that if A is less than 0 and B greater than 0, then the endemic equilibrium is locally asymptotically stable, that when R naught is greater than 1. And same set of parameters which we used for COVID-19 only model and TB only submodel we used. Along with that, few parameters which play some role in co-infection as listed here. And this is the endemic equilibrium dynamics of co-infection model for susceptible population, exposed COVID, exposed TB, exposed TB COVID, and infected COVID, infected COVID exposed to TB, infected TB exposed to COVID, and infected TB, and co-infected individual. Treat people who are under treatment for COVID, treatment for TB, and recovered individuals. Now here I have few variation plots like as treatment rate, as transmission rate beta 1, beta 2 increases, it increases the total infection population and they decrease the recovery rate as shown in figures. Where and here the treatment plays a major role in decreasing the total infection population and increase the recovered population. Next, I just move on to optimal control and cost-effective analysis of co-infection model. Here we have like optimal control is a mathematical approach to determine the best intervention strategy over time to minimize disease burden and or associated cost. Here we have added
Ma'am,
four.
please stand up.
Yeah. U1, U2, U3, U4. We have 4 controls. U1, U2 plays a major role in decreasing the transmission and U3, U4 plays a major role in increasing the treatment. And we divided the scenario into 4 different scenarios. Like first scenario, only one control applied. Here we have 4 strategy. And for cost-effective analysis, we have constructed IAR, ACR, and ICR matrix. In cost-effective analysis, ICR matrix plays a major role. Here the calculation from first table you can find that ICR value for strategy 1 is more, so it is removed and again the calculation redo, and from the second table you can find that strategy 3 is more, ICR value is more and it is removed, and for scenario 1 we have found that strategy 2 is more cost effective from the ICR value. And uh, here I have a plot of IAR and ACR values. Here from this total infection population, it is proved that strategy 2 have reduced the infectious rate comparing to other 3 strategies. Similarly, we do for scenario 2 where 2 controls are applied. Here we have found that strategy 9 is strategy 9 have best outcome. And scenario 3, when 3 controls applied, here we have 4 strategy. And in this also we have found that strategy 12 plays a major role in reducing the cost effective. And here when all 3 controls applied. Now we have specifically done for simple 1-1 scenario. From that different scenario, we have chosen the best control, and overall for all the controls which is best, we are going to just identify that. Same analysis done, and here we for our co-infection model, we have found that scenario 1, strategy 2, that is TB prevention to TB plays a major role in reducing the uh, transmission at a less cost. And here we conclude that developed a compartment model with 12 compartments to analyze COVID-19 and tuberculosis co-infection, and the incorporating treatment compartment for both the diseases. And from R0 value, we found that TB plays a major role, and as transmission increases, infectious rates increases,
Ma'am,
and
please bind down.
yeah, yes, ma'am, I completed. And from this, we found that U2 control is more effective and cost effective. And these are the few references, and thank you.
Thank you, ma'am. Now I invite this is the
And yes.
sir. There are any question for
I think no. Okay, so we'll vote for next present.
Miss Sheena Agrawal.
Kindly
Please share
unmute
your screen.
yourself. Kindly unmute yourself.
Please
Sorry. Sorry.
unmute.
Good morning, everyone. My name is Sheena Agrawal, and I'm research scholar at IIT University, Meerut. It's a pleasure to be here with you all. I'm excited to share insights about my topic, that is the assessing the impact of economic growth on environmental quality, a comparative review of data from Asian countries across different income classification. Over the next few minutes, I will take you through some insights of my topic, and I hope this session will provide valuable perspectives that you can take back to your work. Now I'm sharing my screen with you all. This is the topic of mine. So this is the introduction part, and I want to present that economic growth in Asia has accelerated over the past 2 decades, but this progress comes at an environmental cost. The environmental Kuznets curve suggests that environmental degradation initially worsens but improves after a certain income level is reached. Asia is a relevant case due to the diverse income levels, population pressure, and rapid industrialization. This presentation explores the economic environmental relationship, evidence, and future pathways. This is the gap identification I have going through. Since there are few longitudinal studies, extended time series data should be the main focus of future study to better understand the long-term trends and implications. There are also insufficient evaluations that are sector-specific, looking into the way that various industries like mining, manufacturing, and agriculture affect environmental quality could yield more focused insights. To evaluate the efficacy of governmental interventions and technical improvements in mitigating the environmental deterioration in Asia, more research is necessary. Furthermore, little research has been done on how economic expansion affects environmental services and biodiversity within Indian settings. There is a knowledge vacuum on how economic circumstances and people perceptions affect environmental outcomes in Asia because these aspects have not been thoroughly researched. This is the mathematical model I'm using of EKC environmental Kuznets curve. EI is equals to alpha plus beta 1 yi plus beta 2 yi square plus epsilon I, where EI represents the environmental degradation indicator, for example, CO2 emissions and particulate matter of 2.5 micrometer, deforestation. Yi is for the per capita income of GDP, alpha is for the intercept, and beta 1, beta 2 are the coefficients of time, and epsilon I is the error term. These are the extended EKC models. EI is equals to alpha plus beta 1 yi plus beta 2 yi square plus beta 3 yi cube plus epsilon I, where Zi and the inclusion of controllable variables also, EI is equals to alpha plus beta 1 yi plus beta 2 yi square plus gamma Zi plus epsilon I, where Zi is the other explanatory variables such as trade, population, energy use, etc. This is the visual representation of environmental Kuznets curve, which represents that in the starting, when the GDP per capita is increasing, environmental degradation is also get increased. At a certain level, it get peaked. But after the country, the GDP per capita is consistently increasing, we move on to the green technologies and the other technologies which are helpful for the environment. So the environmental degradation is decreased day by day. This is the EKC framework. The environmental goodness curve shows an inverted U-shaped relationship between environmental degradation and income per capita. Early growth phases increase pollution due to the industrialization. Advanced economies invest in cleaner tech and enforce regulations. Critiques argue that it oversimplifies and doesn't account for all environmental variables for governance factors. This is the EKC framework. In the low income countries, the environmental degradation and the GDP will be at the lowest time. In middle income countries, it is at the highest peak, and in high income countries, it will reduce. It will reduce as we are moving on to the green tech and all the other ways which can save the environment as well. This is the empirical evidence from Asia. Evidence from Asia supports parts of the EKC model, just as low-income countries, for example, Nepal and Bangladesh, see rising CO2 and air pollution. The middle-income nations, that is India and Vietnam, faces peak stress with urban sprawl and industrial emissions. And the high-income countries, for example, Japan and South Korea, show signs of decoupling economic growth from emissions. These are the economic growth trends. Asian countries have shown varied growth patterns, like China and India experienced rapid industrial growth contributing to global GDP. Transition from agriculture to manufacturing and services, and the foreign direct investment and trade are major drivers of growth and environmental changes. These are the environmental indicators. Rising CO2 emission and particulate matter 2.5 micrometer level threaten air quality. Water bodies suffer from untreated industrial waste. Deforestation and biodiversity loss are widespread. Per capita pollution varies widely, indicating uneven development impacts. This is the link between the growth and environment. How EKC fits partially but inconsistently. This pollution Havan hypothesis says that dirty industries relocate to lax regulation countries. Pollution halo hypothesis says that FDI brings greener technologies, and governance, laws, and public investment plays crucial role in this. Effective solution involve both policy and innovation. Renewable energy investments reduce carbon footprint. Green finance, for example, carbon credits, ESG bonds, promote sustainable industries, and smart city projects, better public transport, and waste control technology are emerging. These are the future perspectives of my study that promote regional cooperation for resource and pollution management, assist lower income nations in transitioning to greener economies, and use artificial intelligence in big data for climate monitoring, early warnings, and smarter policy making. So economic growth must be aligned with sustainability, so that we can't be the back leg in the economic growth, but we want to grow economically also, and according to environment also. Asia needs inclusive, tech-driven, and locally tailored solution, and environmental integrity is key to long-term development. Thank you so much. Thank you so much from my side.
Sir, have you any question?
No, we can go with the next speaker.
So I invite Miss Seetal K. Seetal K.
Hi,
Ma'am,
ma'am. Hi,
please.
sir. Am I audible?
Yes,
Yeah,
yes.
you are audible.
Good afternoon, sir. I'm Sheetal, Research Scholar, Department of Statistics, Federal College, Autonomous Kozhikode, Kerala. Today, I'm going to present a review paper based on the topic Advances in Coppola Modeling. Here are my contents. And let me come to the introduction. Coppola modeling is an approach that is frequently used to investigate the relationships between variables. Coppola modeling is also particularly relevant to economic and financial modeling, since it may be used to predict
Your
financial
PPT is not
contagion and
visible.
growth. Excuse me, sir.
Your PPT is not visible. Kindly reshare it.
Okay, sir. Is it visible, sir? Sir, is it visible?
Your screen is visible, but your PPT is not there.
Please share your PPT.
Sir, is it visible?
No, I can't see. Shivam sir, is it visible to you?
No, sir, it is not visible. Only the list of files, the folder is download is visible only.
Yes, yes.
Ma'am, please try to reshare your screen.
Sir, is it visible now?
No.
Ah, now,
Okay,
now it is.
Please
Okay,
go
sir,
ahead.
thank you.
Please go ahead.
Okay, sir. And this is my topic, Advances in Coppola Modeling, a review. And these are my contents, sir. And let me come to my introduction. Coppola modeling is an approach that is frequently used to investigate the relationships between variables. Coppola modeling is also particularly relevant to economic and financial modeling, since it may be used to predict financial contagion and boom or bust times. In recent years, Coppola-based data modeling has gained popularity since it allows one to flexibly choose suitable marginal distributions for the various parts of a multivariate system. The aim of Coppola-based studies is to create more adaptable families of bivariate or multivariate distribution functions with a range of interjoint characteristics such as symmetries, tail dependencies, and broad ranges of association. There are several ways to quantify the dependency or association between random variables, and the Coppola is one that can capture the scale, invariant, or distribution-free character of the association between random variables. And here is my motivation. And I'm motivated to do review on Coppola modeling because of its wide applications in areas like finance, economics, environmental science, medical, biological studies, etc. And a strong research is required to create new Coppola families, enhance inference techniques, and apply them to newly emerging data sets such as big data, machine learning, and analytics powered by AI. Our objective is to investigate novel Coppola structures, expand their use in multivariate risk modeling, and utilize them to address real-world issues where traditional models fall short. And let me come to my review and its methodology. Olivia Scalet and Jean David Firmanian in 2004 discussed some possible statistical hazards when modeling cross dependencies in financial applications using Coppolas. They examined problems that arise specifically in the design of time-dependent Coppolas estimation and empirical Coppola selection. Tanish Kumar Mohammed M. Shafri in 2007 examined that the standard correlation-based prediction models are shown to be inappropriate for modeling dependence in populations with asymmetrical tails, and Coppola-based prediction modeling is shown to be a suitable substitute. To validate the proposed Coppola-based prediction model, the independent bootstrap samples were used. David Gunavan et al. In 2016 defined the likelihood as the density of the observations with respect to a mixed measure extending the research on Coppolas with discrete or continuous marginals to the situations when some of the marginals are a combination of discrete and continuous components. Using Markov chain Monte Carlo for estimate, the inference is Bayesian. By using the algorithms and techniques to estimate a multivariate income dynamics model, they demonstrate them. Paula V. Toffoli et al. In 2017 presented a novel method that combines the Markov switching model with time-varying copulas to explain the dependence between global finance returns over time. They are also curious about how these approaches compare in terms of the dynamics of reliance that occur and how well the models predict potential capital losses. The models are compared and chosen based on value at risk estimates because risk associated with extreme occurrences are significant for risk management. N. Unikrishnan Nair et al. In 2018 explained the qualities of dependability function analogs that are represented in terms of copulas. The copulas of a bivariate exponential family of distributions are used as an example to illustrate the study's findings. They put out some fundamental definitions and finding that make it easier to model lifetime data using bivariate copulas as opposed to the more conventional method of employing bivariate distributions. It was discovered that the mean residual quantile function and the copula-based hazard rate have certain advantage over their distribution-based equivalents. M. Ishak Bhatti in Hume Kwang Do in 2019 examined in detail how copula models have been developed and how they are used in the fields of environmental sciences, forestry, fuel cells, and energy. Copulas have been used in a wide range of energy, environmental, and forestry research, especially when utilizing hydrology to measure the correlation between tree height, diameter, volume, water flow, and energy production. Copula models are also used extensively in hydrometeorology, including earthquake forecasting, wind speed, irrigation, energy prediction, and rainfall forecasting. Noor Amira Gulia and Benti Ling Xin Yi in 2020 analyzed the rainfall volume and duration using a copula for various stations. This study has three specific goals actually. First one, to estimate the correlation between rainfall volume and duration. Second, to fit rainfall volume and duration into a copula. And the third is to determine the best fitting copula. The suggested approach is used to analyze hourly rainfall data from a few chosen stations in Terengganu, Selangor, and Kuala Lumpur and others. The suggested method has the advantage of offering a more adaptable way and to model multivariate distributions for which the volume and duration marginal distributions do not always belong to the same distribution family. Gary Ginens in 2020 investigated the viability of copula modeling for discrete data. It offers a simpler framework that makes copula concepts transfer naturally to the discrete situation. And it is an effort to revive some of Whitney Ewell's century-old concepts as he had previously described a construction akin to copulas. The useful characteristics of higher order odds ratios, particularly margin freeness, are retained. Paul R. Devick and Shuangli in 2022 examined normal copula modeling and financial copula modeling and explained why time series and non-time series copula modeling employ different methodologies. Here, normal copula modeling and financial copula modeling both follow the same process, but financial copula modeling requires that the time series be properly defined. Once the time series have been identified, the copula model may be generated and the uniform marginal distributions can be simulated using a pseudo CDF. A pseudo CDF can be used to simulate the uniform marginal distributions and generate the copula model after the time series have been discovered. Andrea Sancas and Ruiz Su in 2022 examined copula model selection as a challenge related to picture recognition. They provide model selection methods that integrate image features with statistical data, and they use the pre-trained LXNet to extract image features from the heat maps. They used a support vector machine classifier along with dimension reduction by principal component and linear discriminant analysis. Simulation experiments demonstrate that the copula model selection job is more accurate when image data is used, especially when sample sizes and correlations are small. This result suggests that the transfer learning can help with statistical model selection processes. They show how to apply the suggested model to the joint modeling of the RISX and MSCI indices weekly returns. And Xiang Gu et al. In 2023 developed a wine copula model that included rolling judgments and real-time prediction result correction in order to simulate and forecast lake water level. The model was used to forecast array LUX water levels over the short and long term on the Yunhui Plateau in
Hello.
southwest China. As the number of factors increased, the accuracy of the predictions improved, and the findings demonstrated that the daily water level predictions were more accurate than the monthly ones. Additionally, of the three model types, the Wine-Coppola model provided the best estimate of the non-linear relationships between the projected water level and climatic parameters, particularly during the rainy season, outperforming the support vector regression and back propagation neural network models. The Wine-Coppola model's prediction accuracy decreased with small sample numbers and in the absence of runoff data. Seng-Long Shena et al. In 2023 investigated the relationships between actual Chinese industries and the effect of dynamic connections on portfolio risk optimization. They built a dynamic factor Coppola means ES model. They came to the conclusion that, excuse me,
Ma'am, please try to bind up.
excuse me, ma'am,
Ma'am, please try to bind up.
I can't hear it.
Hello, ma'am.
Let me
Hello.
continue.
Ma'am, please try to bind up.
Hello, ma'am.
Hello.
Hello.
Ma'am, please try to bind up.
Okay, ma'am. Dimutu Fernando et al. In 2024 suggested a bivariate count time series model that was constructed with the use of Coppola theory. Here are my different reviews and methodology. And Jonas Esplent and Arkady Shemyakin in 2025 explained about the ARIMA models for the analysis of excess mortality for multivariate nations. And here are the future scopes based on my topic. And here is my conclusion. Coppola models have evolved and are widely applicable in a variety of fields, including risk forecasting, epidemiology, environmental science, and finance. Financial market dependencies over time could now be better modeled thanks to the development of time varying and regime switching Coppola models, especially for risk management applications like war. Environmental sciences applications, on the other hand, demonstrate how well Coppolas may represent intricate interactions between ecological, hydrological, and meteorological factors. Through advances such as dynamic factor Coppolas, Wine-Coppolas, and the incorporation of rolling forecast and real-time changes, recent studies have significantly improved Coppola modeling. These advancements have enhanced the interpretability of multivariate dependencies in systems with temporal and structural complexity, as well as their prediction accuracy. Coppolas have even been shown to have promise in predicting global health, including excess mortality from pandemics. In high-dimensional real-world predictive modeling and decision-making, Coppola models are said to become increasingly more important as methodologies advance, particularly with the addition of machine learning and Bayesian techniques. And here are my references. Thank you.
Sir, have any question?
Huh. I have one question for you.
Okay, sir.
Can you give an example of Coppola in income and consumption dependence modeling?
Sir, in finance, there is so many applications in Coppola based on their output and their forecasting. Also, we can use Coppola modeling in ARIMA models also.
Okay. Thank you.
Thank you, sir.
Go ahead with the next presenter.
I request to all the judge and guests and all the participants to kindly open their cameras for a while so that we can take a screenshot. Sir,
चलो फिर अभी कर लेंगे। हो गया हो गया ना हाँ हाँ हो गया चल रहा ले लिया ना श्वेता पिक कर ले। Kamlesh sir, please on your camera. Kamlesh sir.
Sir, please. Shivam sir, please.
चलो आप ले लो, फिर बाद में देख लेंगे। आप ले लो, लास्ट में एक बार करें। हाँ, so invite the next presenter.
Miss Shivani.
Yes, am I audible?
Ma'am, Miss Shivani.
Yes, yes.
Audible?
Am I? Okay, so can I
Just
present my
minute
screen?
just a minute.
Okay.
Please just a minute. Thank you. Now all the participants to kindly turn off their camera. All the participants are requested to turn off their cameras. Ma'am, please share your screen.
Okay, okay, I'm sharing it. Is it visible?
Yeah.
Okay, so may I start now? Okay. A very warm good afternoon to one and all present here. This is Shivani Kumari, a research scholar in the Department of Statistics, Central University of South Bihar. Today I'm going to present my work entitled as An Improved Class of Synthetic Estimator for Mean of Domain in Missing Data. So the outline of my presentation today is mentioned here. Proceeding with the introduction part. Generally, sample surveys are carried out to get trustworthy estimate at the larger level, like state or country level. But however, when we'll use those estimates for the smaller levels like district, tehsil, block, or village, they won't give us reliable estimate. So to obtain reliable estimate at these lower level, small area estimation methods have been discussed. The word small area refers to a small geographical part or a specific part of the population. It can also be named as small domain. So among the methods used for small area estimation are direct and indirect estimator. So today I'll proceed with the indirect estimator, and the most popular estimator of indirect estimation is synthetic estimator. According to Gonzalez 1973, an estimator is called a synthetic estimator if a reliable direct estimator for a large area covering several small domains is used to derive an indirect estimate for a small domain under the assumption that the small areas have the same characteristics as the large area. In sample surveys, we often get encountered with the missing data. So missing data may undermine the estimator's efficiency and unbiasedness. So we need a specific technique to handle those missing data in order to safeguard the correctness of the inferences we make from the data. So the most popular and acclaimed technique for handling missing data is imputation. So handling missing data through synthetic imputation technique formerly have been addressed by Bhusan et al. In 2024 for the very first time in the field of small area. In the present work, we have suggested an improved class of synthetic estimator for estimating the mean of domain based on imputation technique under SRS WOR, and we have also examined its property, and then we have verified it using theoretical and numerical study. So some of the estimators that have been discussed by Bhushan et al. Have been found as the special cases of the suggested estimator. Coming to the methodology and notations employed, so we have considered a given population omega of size capital N that is made up of d unique small areas that are each in size capital ND. Now we draw a random sample S of size small n from the population omega. For estimating the mean of domain D, we use the data obtained from the sample S that have been drawn from the population omega. Now for the responding set, we represent it by using A, and for the non-responding unit, it is represented by A complement. R represents the number of responding units from the selected N units, and similarly, N minus R will represent the number of non-responding units. Sample values on study variable Y are collected. However, we assume here that the imputation is carried out with the help of an auxiliary variable X, and we have sufficient information regarding that auxiliary variable with us. Now the suggested imputation technique. So by using information on capital X bar D, that is mean of the domain of auxiliary variable, small x bar n, small x bar r, we have suggested an improved class of synthetic estimator that has been mentioned in equation 1. And using this equation 1, the imputation based estimator for the mean of domain is obtained as TS star, that is mentioned in equation 2, where alpha and beta are chosen constant such that it will minimize the MSE of the estimator, proposed estimator. And now the bias and suggested estimator is mentioned in equation 3 and equation 4 respectively. Now the table shows the members of the suggested improved class of synthetic estimator. When we put different values of alpha and beta in equation 2, we get different special cases that has been mentioned here. So we have got in total T1 to T6, that is 6 of the members. Out of these 6 members, 4 have been discussed by Bhushan et al. In 2024. So 4 of his estimators are special cases of the suggested estimator that we have suggested it. And now the MSCs of the special cases has been mentioned here in 1 to 6. For the analytical study, this is the theoretical study. So equation in the points 1 to 6, we have mentioned the condition that will satisfy when the efficiency of TS star surpasses that of estimators T1 to T6. For the numerical study, we have considered the real data set, that is MU284, and it has been taken from the book Model Assisted Surface Sampling by Sandal et al. 1992. So this data set has been divided into 8 non-overlapping regions, 1 to 8, with the respective sizes mentioned here. So from this data set, we have considered 2 different population. Population 1, in population 1, we have considered 4 domains, and the study and ancillary variable is written here. And for the population 2, we have considered 5 different domains out of the 8 domains, and their sizes have been mentioned here. And the study variable and ancillary variable are written here. Now, we use simple random sampling without replacement to choose 1000 independent samples of 20% values of the population. And then we assume that 15% of the values in each sample are missing. So for population 1, we have the population size, that is capital N is equal to 150. So 20% would be the sample size, that is small n is equal to 30. And out of these 30 values, we assume that 26 values are responding unit, and correspondingly 4 units are non-responding. For the population 2, population size is 203. And out of these 203 values, we have drawn the sample of 41. And then out of these 41 values, we assume that the 35 values are responding, and correspondingly 6 values are non-responding. And the formula that have been used to compute the simulated MSE and percentage relative efficiency are mentioned here. And similarly, the table shows the simulated MSE and pre of the suggested improved class of synthetic estimator and its special cases with regard to T1, that is Y bar R, that is the traditional mean method. So we can see here that the proposed estimator, that is TS star, has the least MSE among all the estimators, and similarly highest percentage relative efficiency. This is for population 1. Similarly, for population 2, the same observation have been made, that the suggested general class of estimator, that is TS star, is performing better than all the previous estimators mentioned here, that is T1 to T6. Coming to the results, from the simulation study result presented in the table, we observe that its member T1 to T6 exhibit greater MSE than the suggested improved class of synthetic estimator TS star across all domains. In addition, the estimators T5 and T6 had lower MSEs than the estimator T2 and T3 respectively in each of the domains for both the population. Now concluding it, from the simulation study, it can be concluded that the suggested improved class of synthetic estimator has greater efficiency than the other corresponding estimators such as T1, T3, T4, T6 discussed by Bhushan et al. 2024. And since the suggested improved class of synthetic estimator is more efficient than the other estimators observed, and it also includes the other estimators as its members, so surveyors may be encouraged to utilize it for estimating the mean of domain when they encounter missing data. references that I have used is mentioned here. And thank you. This was it.
Thank you, ma'am. Sir, sir, have any question? Anyone have any question for? Sir, have any question?
Huh. Shivani,
Yes, sir.
can you, how does the proposed synthetic estimator handle different type of missing data technique like MCAR, MAR, and MNAR?
Sir, I have missed that point in the slide. I have assumed MCAR, that is missing completely at random technique. Okay, so it would work only for that mechanism, missing completely at random. I have missed that point in the slide.
Okay, okay. And how is the weight determined for combining observed and synthetic data?
Sorry, sir, can you please repeat it? I could not understand it.
Weight. How is the weight determined for combining observed and synthetic data?
Weight?
Huh.
Sir, I'm not getting the question. Can you please simplify it for me, please?
Okay, no problem, no problem. Okay, no problem. Is there any other question from the participant?
I just have
Okay.
one question. I wish to say.
Yes,
please.
yes.
Yeah. So is there a way like you have tried pattern mixture imputation methods also? Because those methods are also efficient in order to get the better estimators.
Actually, I'm not a very experienced one in this field, so I'm just starting with it. And there is not much literature available, but I would consider that point.
Yeah, because if you go on reading the first specification or the monotone specification lasso regression model, that would be a one step, I would say, ahead of what we are doing in this.
Yes, I agree. But since there is not much work, so we are starting with the basic ones and we'll proceed with it for sure.
Okay, yeah, thank you.
Thank you.
Next.
Thank you, ma'am. Now I invite Miss Shraddha. Miss Shraddha. And next I invite Miss Shreya Mishra.
Hello, I'm audible to all.
Yeah, you are audible.
Good afternoon, everyone. I am Shreya Mishra from BBD University.
Ma'am, please share your history.
Yes, ma'am.
Ma'am, please share your screen.
Yes, ma'am, just a second.
Go to the video option and
Sorry.
go to the video option setting and then you can
Sorry.
share your screen. Firstly, you need to go video option.
Video option, ma'am.
Yeah, video option and video setting and
Ma'am, here video option is not given doc.
a video option in the below. Yeah, your screen visible. Please share your PPT.
This one. Is it visible, ma'am?
Yeah. You can start now.
Sorry.
You can start now. Please remember that you just have 8 months.
Okay, ma'am. Okay. Sorry for you. So my topic is phase transition in interaction of DNA triplex helix with neomycin. The content of today's presentation is introduction, mechanisms of drug and DNA interaction, DNA triplex, minor group binding, major group binding, Zemback theory, order transition, explanation of neomycin, graph of temperature versus absorption for DNA triplex with neomycin and references. Introduction. The deoxyribonucleic acid is a polymer composed of two polynucleotide chains that coil around each other to form a double helix. The polymer carries a genetic instruction for the development, functioning, growth, and reproduction of all the organisms and many viruses. Each nucleotide is composed of one of four nitrogen containing nucleobases such as cytosine, guanine, adenine, thymine, a sugar called deoxyribose, and the phosphate group. The nucleotides are joined to one another in a chain by covalent bond between the sugar of one nucleotide and the phosphate of the next, resulting in an alternating sugar phosphate backbone. The nitrogenous bases of the two separate polynucleotide strands are bound together according to base pairing rule: A with 3, adenine with thymine, cytosine with guanine, with hydrogen bond to make double strand DNA. The complementary nitrogenous bases are divided into two groups: the single ranged pyrimidine and the double-ranged purines. In DNA, the pyrimidine are thymine and cytosine. The purines are adenine and guanine. The two strands of DNA run in opposite direction to each other and are thus antiparallel to each other. As we can see in this figure, the structure of DNA and RNA. Here, this is the sugar phosphate, which is in brown color, and this one is adenine, guanine, cytosine, thymine, uracil. As we can see in DNA, adenine guanine, cytosine, and thymine is there. And in RNA, adenine, guanine, cytosine, and uracil is there. DNA triplets refer to structure formed when a third strain of nucleic acid bind to the double-stranded DNA. In this arrangement, the third strand interacts with the major groove of the DNA double helix through hydrogen bonding with the base pair of the two strands. This third strand is typically rich in purine bases and follow a specific sequence pattern called the triplets forming the oligonucleotide. The DNA triplet structure has been found to have a various application in molecular biology, biotechnology, and medicines. Some key applications are also there. There are mainly two types of triplex DNA structure. Hostagen DNA and reverse hostagen DNA. In hostagen DNA, the third strand binds to the major groove of the DNA helix via hostagen hydrogen bonding, which is different from the standard Watson-Crick base pairing. And the reverse hostagen DNA, the third strand also binds to the reverse hostagen base pairing, but it forms different interaction compared to the hydrogen DNA. Next is minor groove binding. These grooves are formed due to the helical shape of the DNA molecule, and they play important role in the interaction of DNA with various protein, enzymes, and small molecules. Here, an overview of the minor groove. The minor groove is smaller and narrower than the major groove. The width of the minor groove is typically around 5 angstrom, while the major groove is wider, around 12 angstrom. It is located on the inside of the helix between the sugar phosphate backbone and the base pair that form double helix. The minor groove is formed where the two strands of DNA come closer together, while the major groove occur where the strands are further apart. Major group binding. Major group binding refers to the interaction of various molecules such as a protein or a small molecule with a major groove of the DNA double helix. The major groove is the larger of the two grooves, the other being of the minor groove formed by the helical structure of DNA. The major groove play a crucial role in the recognition of the specific DNA sequences, and the major groove is larger and more accessible compared to the minor groove. It is about 12 angstrom wide, whereas the minor groove is about 5 angstrom wide. The larger size allow protein, enzymes, and other molecules to recognize and bind to the exposed base pair more easily. Next is Simback theory.
Ma'am, please try to wind up.
Yes, ma'am. Next is Simback theory, which we have used in our calculations. The Simback theory is a statistical mechanical model used to describe the helix foil transition in polymer chain, particularly in polypeptide and proteins. It was developed by Zim and Bragg in 1959. The Simback theory was suitably amended to study the order and the order disorder transition in DNA triplets. Next is order transition. A DNA triplet structure forms when the third strand of DNA binds to the major groove of the double-stranded DNA. Often, though hostagen or the reverse hostagen base pairing, the formation of the triplets represent an order transition because both the original double helix order and the new triplet structure, another type of order, exist in a specific ordered state. This transition is significant in biological process like gene regulation.
Ma'am, please try to wind up.
Ma'am, just only one slide more. In the same way, order disorder transition. Now the main slide is neomycin. Neomycin is antibiotic that is a part of a aminoglycoside class of antibiotics, which are widely used to treat bacterial infections. So we have used the neomycin in our calculation. So my work is based on, we have investigated the stabilization effect of aminoglycosides on the intramolecular triplex, the melting profile where we conducted the presence of neomycins. We have presented a graph of the melting profile of this DNA triplex at 260 nanometer in the presence of 8 micrometer neomycin. The graph is between the absorption versus the temperature. In the present work, we have done certain calculation using Zimbach theory for neomycin and the duplex for order transition. Here we can see this graph. This graph is basically between the absorption and the temperature, and it is for the order phase transition DNA binding with neomycin. The black one graph is we have taken the calculation from the reference paper, and the red one is we have calculated certain calculation using the Zimbach theory, and here we can see that it is near about exactly matching with the reference paper and our.
Ma'am, please wind up.
Okay. So this is a reference. Thank you.
Thank you, ma'am. Sir, have any question? Sir? Now I invite Miss Samita Dubey. Samita Dubey? Miss Samita Dubey. Are you here? Samita? Next, Dr. Himanshi Sharma. Ma'am.
Hello.
Dr. Himanshi Sharma.
Hello, am I audible? Hello.
Ma'am, please share your screen.
Okay. Is my screen visible? Good afternoon, everyone. Myself, Dr. Himanshi Sharma, Assistant Professor, Department of Basic Sciences and University of Noida. Today, I'm here to
Ma'am, please try to wrap up your presentation within 8 minutes.
Sure, ma'am, sure. Today, I'm here to present my presentation on Bayesian estimation of parameter in M1 model with inpatient.
Ma'am, your voice is so low.
Hello.
Hello.
Hello. Am I
You are
audible?
not audible, ma'am.
Hello, am I audible?
Ma'am, your voice is too slow.
Hello.
Yeah.
Hello, am I audible?
Hello.
Hello, am I audible?
Hello. Yeah, you are audible, ma'am.
Okay. So these are the table of contents of my presentation, and this paper focuses on Bayesian inference of an MM1 queuing model with bulking. So this is a phenomena where customers choose not to join a queue due to long waiting line. And in this paper, we focus that we consider this bulking probability as a functional form, not as a constant probability. And this functional form will depend on the number of customer as well as their impatience level. So further, we found Bayesian estimates for traffic intensity using various prior distributions, and finally, we conducted a simulation study to obtain the numerical estimates for the model. So as we all have experienced queue at somewhere like grocery shop, ATMs, bank, etc. So what is queue? So queue is nothing but a phenomena where customer wants to serve, and the question arises in our mind that why we need to wait. So the answer is simple, that whenever the demand for service exceeds the capacity to provide that service, queue will be formed. And queuing system is nothing but an imitation of the practical situation where customer arrive into a system, and he will wait if service is not immediately available to him, and depart after getting served. So this is the complete structure of queuing system, and there are some characteristics of queuing system such as arrival pattern, service mechanism, number of servers, capacity of system, and queue discipline. And all these characteristics have notated by Kendall in 1951 as A/B/C/D/E. And further, these are the characteristics. Now, in this paper, we focused on single server Markovian queuing model, which says that arriving customer follows the POISA process with arrival rate lambda, and service time is exponentially distributed. There is only single server in the system, and the queue discipline follows first come, first serve pattern. Further, when we found in the literature of parameter estimation, we found that there is no such literature on MM1 queuing model with bulking, where bulking function is taken as a functional form. So in this paper, we tried to fill this gap using the bulking probability in a functional form, which depends on the number of customers as well as their impatience level. So using this from this graph, we can understand the behavior of impatience level and the number of customer, how they affect the probability of customer joining. So from this graph, we can observed that with low impatience level, first, we observed that as the number of customer increases, the probability of joining a queue is decreases respectively. And when we see that a lower value of impatience level shows the slower decrement, that means the customer are more interested to join a queue when queue is longer enough. And the larger value of impatience level, which is denoted by gamma, indicates the rapid decrement in probability of joining a queue, which implies that even with slightly higher number of customer in queue, customers are more likely to buy. Further, here is the model. We in the classical MM1 queuing model, we use the probability function, which is taken as e to the power minus gamma x plus 1, and we put this probability function in our classical MM1 model, and we finally found the probability mass function, which is denoted given in equation 1. So further, after calculating all these equations, we finally found the probability mass function, which is given in equation number 5. Further, we applied the Bayesian methodology on traffic intensity, which are parameter of interest. So first, we construct the likelihood function using the equation number 5, and after that, we construct posterior distribution under different kind of prior distribution. As that parameter traffic intensity will lie, we assume that it will lie between the interval 0 and 1. So our prior distribution is taken as beta prior, truncated gamma prior, and the uniform prior, and these are the posterior distributions under all these prior. Further, we apply a squared error loss function, which is also known as symmetric loss functions, and these are the Bayesian estimators for traffic intensity or rho for beta prior given in equation number 16, with relative posterior risk given in equation number 17, similar as for truncated gamma prior for uniform prior. Further, we conducted a simulation study as all these previous equations pose analytically challenges and cannot be solved directly. So we use a popular non-iterative Monte Carlo method called sampling importance resampling simulation, and we use different sample size, and also we use different true value of parameters such as 0.5, 0.7, and 0.9. And these are the numerical estimates for credible intervals, length of credible intervals, posterior risk, and all these numerical estimates are shown graphically to better visual these results, as this figure shows the Bayesian estimates of rho for theta prior shows that as we increase the sample size, our estimated value for rho converge towards the true value with decreasing mean squared error and decreasing posterior risk as well as their length of credible interval. So we break down our interpretation in three points according to number of customer, according to impatience level, and according to priors. So first, according to number of customers, we see that Bayesian estimates converge towards the true value as sample size increases, and With the increase of sample size, mean squared error is decreasing respectively. So our estimates are becoming more accurate, less biased, and more precise. Additionally, when we talk about according impatience levels, so we found out that as it is not noticeable that as the number of customers in the queue increases, the probability of customer joining the queue decreases. Additionally, there is another factor affecting this joining probability, which is the impatience level gamma of customer. And from this from these graphs, we observed that with 0.3 and 0.5, results provide a faster convergence toward the parameter actual value in comparison with higher impatience value, which is taken as 0.7. Further, according to prior, we found out that beta prior provides a better estimate as compared to other priors such as truncated gamma or uniform prior. And here we can say that using beta prior, our base estimates provide a good convergence. And these are the references. Thank you so much.
Thank you, ma'am. Sir, have you any question?
No question from my side.
Now I invite Miss Samita Dubey.
Hello. Good afternoon, ma'am.
Please remember that you just have 5 minutes.
Hello. Good afternoon, ma'am. Good afternoon, sir. My name is Smita Dubey. Ma'am, is my screen is visible?
Yes, yes, ma'am.
Your
Please
screen
continue.
is visible, but remember that you just have 5 minutes.
Yes, ma'am.
You just have 5 minutes for your presentations. So try
Okay,
to
ma'am.
wind.
Ma'am, my topic is toxicity of metals in groundwater. First of all, I would like to give a general introduction about groundwater. As we know that groundwater is very much essential for us, but nowadays it became toxic due to human beings or natural sources. My whole work on my research is that to identify the toxic metals which are present in groundwater. These are the objectives of my title. Now, my first objective is to assess the occurrence and distribution of heavy metals in groundwater, to determine the potential source of heavy metal contamination, distinguish between natural and anthropogenic activities, to analyze groundwater quality using advanced assessment and monitoring technique. Now, fourth is to explore and develop sustainable remediation technique for heavy metal removal.
Ma'am, kindly
No,
come to your research only. We will just focus on the research.
sir, my my research work's main aim is to introduce the toxic metals. What are the toxic metals present in groundwater? That work is going on still. So I have selected Lucknow city for collection of groundwater for testing. Nearly, I divided this city into four main zones according to population distribution and urban development. The four main zone which I had selected, I collect 8 to 9 key areas for each zone sample, and these are the pictures where I collect from the sample. Now my whole work is on going on double AS, atomic absorption spectroscopy, because these technique are very advanced and give a proper sampling testing. Still my testing is going on. So these are the process how I do sampling of my groundwater, and these are the application of double AS, and the advantage and limitation of double AS are these. So currently I'm doing only arsenic and mercury. Still 2 to 3 days my result is coming, but still my work is going on. So these are the processes how I am doing my work on this.
Why you have targeted only these two, mercury and arsenic?
Sir, not targeting only these. I have selected 2 to 3 more sample for test. 2 to 3 more metals. Because but starting from this mercury and arsenic, because mercury is more harmful and it creates a severe health problem.
Thank you very much, Smita, for your presentation.
Thank you, sir.
Thank you. We can switch to next speaker.
Thank you, sir.
Thank you, Miss Samita. Now I invite Dr. Selva. Dr. Shaija Pandey.
Salja ma'am, are you there?
Dr.
Namaskar, Salja ma'am.
Namaskar, sir.
Please.
How are you, sir?
I'm fine, ma'am. As we are going to start the valedictory, so we are running short of time. So please.
Okay, sure, sir, sure.
Yes, ma'am, please go ahead.
Good afternoon, good evening, everyone. First of all, I would like to thank the organizers of this conference for giving me the opportunity to deliver a short invited lecture. Today, my theme of my talk is basically an effective imputation framework for successive sampling with missing data. Here is outline. Just a second. So imputation is a widely used, basically here in this talk, I'm going to discuss work related to successive sampling in presence of missingness. So imputation is basically a technique which handle this missingness. So imputation is widely used approach for addressing missing data, which remains a critical concern for survey statisticians. So in this particular paper, we propose here a novel generalized class of chain type estimators for estimating population mean on current occasion. Suppose we have 2 occasions, so second occasion is our current occasion. Okay. Theoretical properties we have derived by utilizing data of women and men in India 2022 reports. This is published by Mosby. Successive sampling uses partial replacement across occasions. Missingness commonly occurs in this kind of situation. So here in second point, I have mentioned or literature, what available till date. Our aim is here to develop imputation frameworks and optimal class for current occasion population mean exploiting auxiliary information. And our approach is by proposing a generalized chain type class under different frameworks and derive optimal mean square error under replacement policy. So here is mechanism basically how we draw our sample in successive sampling. So suppose we have here population. First we draw n sample at first occasion. Here R1 is our responding units and n minus R1 is our non-responding units. So in second occasion, we draw a fresh sample of size U unit in which R3 units are responding. Here R2 units are responding. M minus R3 are non-responding, U minus R2 are non-responding. So this M units are coming from our first occasion and U units are coming from our remaining data from n minus n. So basically this m plus u is equal to size n. So that means at first occasion we are drawing size n, at second occasion also we are drawing size u. We are drawing size n. That means n is equal to m plus u. M plus u. M units are coming from here and u units are coming from n minus n. So this is basically mechanism to draw our sample in successive sampling. Now our concern is for suppose here is missing in S, where here n minus r1 units are not responding, or some way you can say data is missing. M minus r3 also u minus r. This is situation of worst situation. That means at first occasion also units are not responding, at second occasion also in matched and unmatched proportion. So this is our mechanism for estimating all these units. We have here our estimator t is equal to phi tm star plus 1 minus phi tu star. Here is regression estimator we are going to use for current occasion for unmatched proportion. So this is imputation framework basically. Here is tu star. This is our estimator. With the help of this framework y dot I, we are computing this estimator, point estimator. In similar way, here for mass proportion also we are computing our tm star. This is also regression estimator. With the help of this framework we computed this one. So as in previous slides, here is tm star and tu star. So on the basis of above, we are able to write tu dash, tm dash. Tu dash incorporated in tu star and tm dash incorporated tm star.
Ma'am, please try to wind up.
Okay. Properties we have derived for tu dash and tm dash. Here is our final estimator of minimum variance of t. Here we have derived our variance. Various special cases we have derived all possible situation of missingness we have considered. For each case we have proposed estimator, derived its properties. For unmatched proportion, we have considered optimum replacement policy and computed theta optimum by utilizing this equation. We have computed loss by utilizing generalized class of Pandey 2020. This is generalized class. We have computed generalized class. We have proposed generalized class in case of missingness. So here is loss. With the help of this formula, we are able to compute our loss by using these two data set. We have computed our numerical study. So here is whole compute study I have added in this table. I will provide. For each, if you see, we have unmatched proportion, we have loss. For each case, I have also computed, see, LP3, LP4, LP5, LP6. So basically in this article, we have suggested various optimal imputation frameworks. With the help, we are able to handle situation of missingness. And it is our firm belief that the proposed generalized classes will play a key role under the suggested novel imputation frameworks. And empirical research shows practical percentage relative loss. The findings leads to practical recommendation for survey statistician, and future work is extended to complex stratified designs, robust estimation, multi-occasion settings. All references are mentioned here. And that's all by my side. Thank you.
Thank you, ma'am. Sir, have you any question?
Thank you, Dr. Shalja. What nice presentation. I want to ask this question that can this framework be applied to longitudinal data?
Yeah, sure. We are able to apply.
The other practitioner has
Okay. No problem. Thank you. Go ahead with the next presenter.
They are more experienced. They are more.
Now I invite Dr. Sangmitra. Ma'am, are you there? Dr.
Hello, ma'am.
Sangmitra.
Good afternoon.
Good afternoon.
Just wait. Ma'am, previous slides are already available. Previous PPT available hai.
Ma'am, please share your screen.
Just wait, ma'am. Hello, ma'am. Hello, ma'am and sir. Good afternoon. My topic is statistical modeling, advanced in statistical modeling, techniques, application, and future direction. My name is Dr. Samita Sharma, Assistant Professor, School of Sciences, IMT University, Meerut. Statistical model. Statistical modeling is a process of the applying statistical analysis to the database to create a mathematical representation of the underlying process and the generator of the data, which helps identify the relationship between the variables, make predictions, and quantify that uncertainty. But foundation and classical technique, that is role of statistical modeling, classic technique utilization, limitation of classical model, need for the advanced technique. We use the statistical modeling to transfer unstructured data inside the prediction and decision making in research. Time series analysis, logistic regression, these are the classical technique utilization methods. And classical model face challenges such as assumption, violation, multipolarity, overfitting, and security issues. Advanced modeling methods are needed to handle complex data and deliver robust, interpretable results. Advanced in statistical modeling techniques, that is in define the Bayesian inference hierarchical model. We use the many Bayesian inference, the posterior and prior in distribution. That is Bayesian inference updates beliefs using new data and prior knowledge, providing full posterior distribution. Hierarchical basis model, hierarchical model account of group level variation, enabling partial pooling for improved estimate stability. Application and benefits, these models enhance the analysis and risk assessment, medical research and education for capturing uncertainty and group effects.
Please remember that
Hello?
Ma'am, please remember that you just have 5 minutes. So,
just wait. Machine learning and statistical integration. We have the main points, hybrid modeling approaches, label methods, neural network, and transparency, imputable, and CAN. High dimension and the space data modeling. Challenges of high dimensional data. High dimensional data includes the computational inefficiency, multimodality, and overfitting challenges. LASSO, that is means the LASSO is the least absolute linkage and selector operator, and it's a parity string coefficient to zero, reducing model complexity by selecting key variables. Elastic net regularization, that is means elastic net has combined L1 and L2 penalties, balancing specificity and stability in correlated predictor. Adaptive LASSO innovation, adaptive LASSO improves model flexibility with data-driven penalties, enhancing performance and interpretability. Non-parametric flexibility, Gaussian process, spline smoothing, semi-parametric model balance. We know about we have mainly two types of parametric and non-parametric. We use the semi-parametric model for the inference, Bayesian inference. Semi-parametric model combine non-parametric flexibility with the parametric interpretability, widely applied in survival and environmental studies. Application of statistical modeling, optimization in 2D materials, statistical design experiment,
We use the design of experiments with AI machine learning. Design experiment provides systematic optimization for synthesis parameter, reducing experiments and improving reproducibility, machine learning integration, predict material properties and status outcome for the data sets, enability, exploration of the new design space, and closed loop optimization. Self-driving labs use real-time feedback to retain models and interactivity, improve experimental results. And statistical anxiety in psychological, because statistical model in use in a medical areas and biological areas. So we use causes, that is many causes statistical anxiety, impact of metatic forces, vulnerability, stress model, and perfectionists, and an anxiety sensitive. Healthcare and epidemiology.
And please try to wind up.
Okay, ma'am. Just wait, but can data, that is in, we use the data quality and missing values, privacy and ethical concerns, and conclusion is methodological advancement, high dimensional technique, machine learning integration, and casual inference application. These are the references. Thanks.
Thank you, ma'am. Sir, have any
Thank you,
question?
Okay, thank you.
Question. Go ahead with the next.
Now I invite Miss Salini Jaiswal. Miss Salini Jaiswal. Miss Salini Jaiswal.
Yes, ma'am. I'm presenting.
Please share your screen and remember that we just have 5 minutes.
Okay, ma'am. If my screen is visible?
Yeah, your screen is visible.
Okay.
You can
Thank
start.
you. So my topic is on from policy to practice multivariate analysis of higher education teachers' perceptions towards NEP 2020 in Uttar Pradesh. I am from Department of Statistics, University of Lucknow. So my topic cover introduction, methodology, data collection, results. National education policy is a transformative reforms in India education system aiming to develop individual with versatile abilities equipped with the demand for 21st century skills and holistic development. In this study, we have 1 minute. Sorry. In this study, we have examined the faculty perception of the national education policy implementation across the higher education institution in Uttar Pradesh, utilizing multivariate statistical technique, including principal component analysis and canonical correlation analysis, to identify the underlying factor structure and access policy impact on the academic community. So for this study, study was sponsored by the Center of Excellence project from the Department of Higher Education, Government of Uttar Pradesh. And the study collected the data from the various government institutions across 4 regions of Uttar Pradesh, Eastern, Western, Central, and Bundelkhand region. And we have selected at least one district from the East region, which the district was which have the NEP implemented in their institutions. A total 108 teachers' response were taken, and the data was collected through a questionnaire based on the NEP 2020. So in this paper, I have used the chi-square method for the descriptive statistics and the principal component analysis. The principal component analysis transforms correlated variable into uncorrelated component that capture maximum variance, and Kaiser criteria to retain component with eigenvalue lambda is greater than 1. This study extracted 5 component explaining 58.49% of total variance, and the canonical correlation is used to find the correlation between the 2 set of variables using the formula given in the slides. So these are the descriptive statistics of the question we have asked in the NEP questionnaire, that awareness about the previous education policies, in which 73% teachers were aware, whereas 27% were not aware about the reform about the previous policy of education policies. And 96% of education systems, 96% of them wanted that there was a need to reform the education systems. These are some descriptive results which we have asked to the teachers that NEP co-curricular courses, research at graduation level, and fieldwork etc. will provide opportunity to students for multidisciplinary work, included academia, government, etc. So approximately we can say that 80% teachers agree with the fact that there was need to introduce the research at graduation level work, and elective paper co-curricular courses will be also beneficiary to students. These are some descriptive frequency distribution for the question we have asked. And these are the chi-square statistics of association between the different region of Uttar Pradesh and various aspects of NEP 2020, where we have seen the significant association between the regions and the questions related to the NEP reforms. Further, in this research, we have analyzed the, we have applied the principal component analysis to structure the questions. Then the data suitability assessment was done with the KMO and Bartlett test results. The KMO statistic shows that the measure of sampling adequacy was 0.830, indicating the data were suitable for factor analysis, and Bartlett test of sphericity was significant, confirming correlation among variables were sufficient for the PCA. So total variance explained were the 58.49% for the questions, and there were 5 components were extracted. The first component was extracted is elective papers and co-curricular educations, and the highest component that teachers suggest that the elective paper co-curricular courses will be beneficiary to student, and after that the co-curricular courses in UG program will help to improve the students' personal skills. The component 2 was the access, equity and educational reform. Component 3 and 4 were technology and multidisciplinary education. Component 5 were the research-oriented studies. In this privatization, quality concerns were high component factor, and research integration were less than the privatization quality concern. So in this, we have obtained the 5 factors. So we have applied the canonical correlation to see the correlation between the factors. Factor 1 and factor 2. There was a 5.37 correlation between the factor 1 and factor 2. In the canonical correlation, we apply when we have 2 set of attributes, and in one set, when there is a more than one variable or 2 variable, then we apply the canonical correlation coefficient. The loading factor for factor 1 and factor 2 shows the correlation. Elective paper and co-curricular courses will be beneficiary to students, shows the 56.5.
Ma'am, please try to wind up.
Yes, ma'am. So these are the canonical correlation for factor 1 and factor 3. So our conclusion is the graph provide the insight into the survey participant perception and opinion regarding various aspects of NEP 2020. The high level of awareness about previous education policy reform, coupled with the overwhelming belief in the need for reform, suggest a general acceptance and readiness for the changes proposed by the NEP. The positive response toward the multiple entry-exit option in bachelor indicate a recognition of the potential benefit for this flexible approach. However, a considerable proportion remains unconvinced, which may require further clarification and awareness raising infer. So factor 1 shows the 60.3% variation explained. Factor 2 shows the 14.8%, and factor 3 shows the 10.9% variation explained. The canonical correlation obtained with factor 1 were 0.647. So study limitation is that the sample size is very small, approximately 200, and convenience sampling limited generalizability, cross-sectional designs restrict casual inference capability, and geographical limitation to Uttar Pradesh institutions only. Thank you, ma'am.
Thank you, ma'am. Sir, have you any questions? Sir? Okay, then I invite Mr. Neeraj Singh.
Okay.
Please share your screen and remember that you just have 5 minutes, so try to bind up within 5 minutes. Okay. Please share your screen. Go to the video option.
This is visible.
Your slide is visual now. You can start now.
Like,
Please start.
good evening. My topic is the study of probabilistic automata within the topological framework. Like here, generally, I was trying this. There hasn't been work on this area. So first, I was trying to define so that we could
Thank you, sir.
try to study if the probabilistic conditions. Like first, probabilistic automata is just an extension of the automata that aligns, that assign probability to transition functions. Here, like the topological framework structure is not constructed. Like there has been a study that shows it is a topology and they go to monoid chains and all. But there hasn't been a much study. So I was trying to first construct, define, then I was trying to go to investigate the topological concepts. First, this is the general definition that is used by Robbins and Stollinger, where the probabilistic automaton is like a five tuple, where Q is defined as the finite set of states, sigma is the finite input alphabet, then sigma mu naught is the initial state distribution, and F is the accepting state, then delta is the transition distribution function. Like here, the transition function, the total summation will be equal to 1. This is a general definition we got from the probabilistic automaton. So from where I was first to define a topology, I was first define a set, a universal set here P and M. This is a universal set for as a collection of all the probabilistic automaton that is defined on this five tuple. So when we define, after we fix the finite values n and m on the number of elements in Q and sigma, we can see, like we can make a space that is made from this delta transition function, so that we can study the topological space. So first, to study the topological space, we define a subbasis as this subbasis is a collection of all subsets of P and M of the form S equal to this P is a subset of P and M, so that the probabilistic value of string from string W is between A to B. Like A to B is from 0 to 1. Like the value should be between 0 to 1. So this is the general subbasis I define. From the subbasis, I make a intersection. Like, so when I do the testing, like we can see that all the intersecting, I mean the basis be formed by all the finite intersection, it is still like coming out. I mean, we can form a basis B. So from the basis finite intersection, like all the possible finite intersection, we make a union of all those possible basis B. Like we can define a topology tau. This is like tau. We can. This is a general like take from my subbasis. So from the subbasis, we can generate this. Then we test if the topology I found tau L is a valid topology. So when I check the axioms, like I could see that, I mean, the phi is an open set in tau L, then the entire space tau L is also open in tau L. So from this we can see the axiom 1 is satisfied. Then the axiom 2, mainly the arbitrary intersection, we can see from the definition that the union of basis, like it is I mean all the unions, like the arbitrary union is also a union of all the unions, so it will generate same huge tau. So the union of all this open set, it will generate an open set. Then the finite intersection, we can see the finite intersection tau L, like is also in tau L, and that if we take any union like sets U1 and U2 from the tau L, like we can see the intersection is a basis formed by the intersection of the subbasis, like both are made from the intersection of subbasis. So the intersection is also an intersection of the subbasis. So it generates open set. So from here, all the axioms are verified. So we can see this topological space. Then, like I was trying to construct tests for convergence, but like within the week I was not able to find it. Then for the continuous function, we define the function f, so that, I mean, f from p1 tau to p2 tau, this is continuous if f inverse v, like it is open in tau if for all open v that belongs to tau, yes. Like, so for this, when I was trying to test the continuous, like I was not able to find this as a continuous, because for the function p, that the transition are the deterministic value, that is either 0 or 1, like the codomain of, like it is making a discrete topology, like where the single set 1 is an open set. The single set, the premise of the single set 1 is a set of all the deterministic function d. This function, like to be continuous, d must have a open set. But like when I am try to find the deterministic value, that we can find a neighborhood, but from the neighborhood we can see that the value, if the value is very close to 1, but it is not lying in the codomain 0 to 1, like, so which lies outside of this codomain. So we can from it we find that the probability the values are not deterministic. Like first we were trying to find if it is deterministic, but since the value doesn't come out as deterministic, we like see if this is the this that the value it is not open set, so the function is not continuous. Like from here I was trying to find the next, but since it is not coming out continuous, it was not able to define the following properties. So for this, I mean, this is the end of this slide. Thank you.
Thank you, Mr. Neeraj. Sir, have you any question?
No, we can go with the second. Yeah.
This, now I invite Mr. Lalit Singh. Mr. Lalit Singh. Mr. Lalit Singh, are you here? Mr. Lalit Singh. Mr. Lalit Singh. Please unmute yourself. Mr. Tab Shah. Mr. Lalit Kumar and Mr. Tab Shah.
Lalit Singh is speaking, ma'am. Good evening, ma'am.
Yeah, good evening.
Sir,
Please share your screen.
uh, I want to join third laptop, but after 5 minutes.
Please share your screen. Please share your screen. Mr. Lalit Kumar, please share your screen. Otherwise, we will proceed to close the session.
Ma'am, my meeting registration is not completed through laptop. I am trying to join.
Please. Otherwise, we will proceed to close the session.
Good evening, ma'am. I am speaking Lalit Kumar Singh. I tried to join through laptop, but registration is not completed through laptop.
Please send your PPT to me.
Please present.
Sir, my topic is flood plain erosion and displacement in Uttar Pradesh, the need for institutional response and policy intervention.
Sir, firstly, you need to send your PPT to me.
PPT, I want to share through laptop. In laptop, but it is not.
Please share your PPT online.
Yes, ma'am. Yes, ma'am. I am trying. I am trying through laptop, but it take time. Yes, ma'am.
Just join. Just join.
Audio.
Go to the share screen.
Ma'am. Trying to connect. Ma'am, I saw through hard copy.
Sir, you want to give full presentation hard copy of the paper. It's fine.
Go ahead.
I said.
It's fine.
Yes, ma'am.
Yeah, your screen is visible now, so you can.
Yes.
Please share your PPT.
Ma'am, so mobile, I saw my PPT and present. Ma'am, my study area is the focus area is the middle reach of Sarda River near Lakhimpur Khir district, especially between the afflux band of the Sarda barrage. Afflux band zone narrow, the river conditions between embankment causes higher flow velocities and bank undercutting and severe erosion during the high flood. My methodology is secondary data, district flood management plan, central water commission records, and remote sensing and GIS data. Social survey में मैम structural questionnaire among 150 household displaced between 2018 to 2023. Field observation में मैम transact across eroding bank and displaced site 2023 monsoon. Government report में State Irrigation Department, NDMA, UP Disaster Management Authority and census record. Result: housing and infrastructure, schools, health center and roads within 2 kilometers of the bank damaged repeatedly. Hotspots: confluence, meandering bend and narrow embankment zones exhibit the highest erosion rate. A spatial shift में satellite analysis show in the Sarda shifted eastward by 320 meters on average between 2000 to 2023. Discussion में मैम 25 villages established between the Sarda River and light afflux band of Sarda Barrage. Total population of 1971 is 19,972, which has increased in 65,444. In upstream of Sarda Barrage, 0 kilometer to kilometer 5.5 up to village Jamunia is submerged are Sarda Barrage, which rehabilitation compensation has been given at construction time, but kilometer 5.5 to 28.5 up to village Narayan Purva between both afflux band, that area is floodplain zone. In that area, no rehabilitation compensation has been provided by the government. Village Manaha has been completely destroyed by the erosion due to flow of Sarda River, and many villages are adversely affected by the erosion caused by the Sarda River. Landless and marginal farmers are disproportionately affected. Gendered impact, loss of women land titles, disruption of the girls' education was observed in the survey. But there is not any policy or government order regarding who established and before publication of above gazette. The villagers who established from 1971 to times at that times the construction of afflux band and who has not received any rehabilitation compensation despite facing several challenges in their basic lifestyle activity. Recommendation है मैम policy making by government institution in favor of the villagers who were established before construction of irrigation structure like barrage, dam, etc. and did not receive any rehabilitation compensation. Erosion zonation mapping, integrated erosion risk layer of the UP disaster management GIS platform. Early warning of the erosion. Develop predictive model combining hydrology and sediment transport and anticipate bank failure. Land banking and planned relocation. Identify the secure site in advance with
Lalitji,
basic
please
infrastructure.
conclude. Lalitji, please conclude.
Ma'am, last page, ma'am. Last page has. Land
Please
bank
try to
and
wind
plan.
up.
Secure the site. Last page है मैम. Last में है सर. Conclusion. Floodplain erosion in the Uttar Pradesh is not just an environmental issue, but a social, economical, and governance challenge. Our findings from the Sarda River stage highlight the urgent need for comprehensive institutional responses that go beyond relief to proactive risk reductions, planned relocations, and sustainable land management. Thanks, sir.
Thank you, Mr. Lalit. This
So-
concludes our session.
Sir,
Thank you to
sorry,
all the
ma'am.
participants and judges.
Sorry, ma'am, I cannot join through laptop and I.
No issue, Mr. Lalit. Thank you very much for joining. Thank you.
Thank
you
you,
to
sir.
all of you, and thank you to all the participants and judges. Now this session.
Thank you.
Thank you, Kamlesh sir, chairing session. And thank you all the participants for actively participating.
Thank you very much, Dr. Shivam sir, and all the participants along with Shweta. Thank you very much.
Thank you, sir. Thank you. Okay.